soon. Yes, so welcome everybody. This is let me introduce you to the next keynote speaker. It's Joseph Delfa. He's a PhD student from the Department of Media Technology and Interaction Design at KTH in Stockholm. He focuses on how small drones can be manipulated by different parts of the body through changes in movement, breath, or balance. So, Joe, the stage is yours.
Hey everyone, I'll just share my screen. Okay, thank you everyone for joining me in this talk about moving a drone with your body. Yeah, so I'm a PhD student at KTH Stockholm, and today's talk will be mostly about my two main projects, which are called Drone Chi and How to Train Your Drone. There will also be two chances for you to have optional audience participation and move yourself. It can be standing or sitting, so look out for that. My work exists primarily within human-computer interaction, or HCI, massive field with links to computer science, neuroscience, psychology and ethnography. And it wasn't until I found people in HCI doing industrial design practice that I was able to kind of understand HCI through a design lens. I was a product design engineer before I started my PhD, so that really helped me kind of find my feet. Others in this space, the Exertion Games Lab in Melbourne. They have done work around jogging with a drone, which is more of a exercise game take on human-drone interaction. The media and interaction design team at KTH have done work around dancing with a drone, a take on HCI that's closer to the arts, the performing arts. Simon Fraser University in Canada have work around slow design, where they put very polished prototypes into the homes of people and test them over long periods of time. And finally, the Performing Objects Studio. This is some work coming out of Copenhagen, where there's like a lot of non-anthropomorphic robots that are kind of halfway between a human and a thing. So I like that kind of ambiguous space that they play in. One last thing before we start looking at drones is that I'm not here to answer the question, what could we use drones that move with your body for? And that's because this work is more of a project or an exercise in design research, which is like a really fun type of design where you get to make stuff without any clients and market demands and brand identities and things like that. So it's this active process of ideating, iterating, and critiquing your designs as you try to make the right thing, which basically just means let's start making some human-drone interactions to learn some things about human-drone interactions. So the question that's more at the front of my mind is, what is it like to move a drone with your body? We don't even know what it's like yet. So I designed Drone Chi to start answering this question. And this is a prototype that's designed to facilitate slow movement and exploration of movement and reflection on that movement. It's primarily achieved by making you aware of how you move, breathe, and balance yourself. So this is how it works. You begin by taking a flower from a vine. Then you put your hand pads on, one for each hand, and your hands curve around the pad. Once the drone is in the air, you're instructed to move your hands around so that to explore what makes the light bright. Then the drone starts moving around in a circle, and you follow this circle as it gets bigger and bigger and bigger, and the light also starts to turn pink. Finally, control switches over to you, and you are tasked with moving the drone, but it requires a lot of coordination and slow movement. So now is time for some audience participation. I want you to take your hands and place them in the same position that I've got here in the picture, kind of like facing down a little bit towards the ground. And I want you to slowly twist both of your hands so that your palms are facing the roof. And then twist them back again so that they are in almost perfect synchrony. Now you notice things like maybe your hands are shaking, or maybe they're slightly out of sync with each other. But I want you to do the same thing now, but imagine that there's a drone there. So you have to picture the drone beneath your hands, and then in between your hands, and then above your hands as you move, as you twist your palms up and down. So you may have felt a difference in between these two types of movement. One, you may have felt an attention being split between your hands and the drone or your imaginary drone. And you haven't kind of had to manage where you place your attention. And this is kind of like what drone chi feels like, for me at least. So the design of drone chi is mainly rests on two design disciplines. One is soma design, and soma design is a design aims to create applications where the interactions subtly support your attention inwards towards your own body, enriching your sensitivity to enjoyment and appreciation. Basically, if you can better develop your ability to reflect and on what you are feeling when interacting with technology, you are better able to appreciate and create your lived experience. So a typical example here is called mediated body, and that uses the act of touching another person to modulate electronic sounds. It's really like a platform to explore the social dynamics of touching another person in a playful way. And it has normally a facilitator there to guide you through the system and kind of to create that help create that fun, playful, dynamic aesthetic. The other design discipline is product design engineering. And product design engineering is the convergence point for engineering and design thinking practices. It's motivated by things like user-centeredness, manufacturability, and cost. There are no facilitators in the final product. So in the design of this office chair, for example, the levers and knobs need to be intuitive and within social norms. The design process would be familiar to a lot of designers. There's mood boards, sketching, prototyping, all that stuff in an attempt to meet user requirements within engineering limitations. So getting started with drone chi, if we take a look at the raw materials of what we've got a drone and a motion capture system. And a drone, has these blades, they're spinning, they can be quite intimidating for some people. There's concerns about privacy and military drones, and they can be noisy, and so not the kind of materials that you want to start with for like a reflective experience. But there's some technical challenges, like they can't carry much weight, as you all know, and they have the arrangement of the markers need to be in a specific place. But what the motion capture does enable is direct manipulation. So when I first started moving with these drones, I immediately recognized their potential for a reflective experience. They command your attention and keep it, and your movements are intimately tied to the drone. there was definitely something meditative about it that needed to be cultivated. And so I took Tai Chi classes to do this. And three aspects of the Tai Chi classes came through that I wanted to bring into the design, and that was coordination, slow movement, and imagery. Um, and what I mean by imagery is just imagining that you are doing something else, or being somewhere else, or maybe even being something else. Very similar to the kind of exercise that we did just before. At the same time, there were these more traditional product design engineering practices going on. I was looking at radially symmetrical objects in nature, living things in nature like mushrooms and jellyfish, and trying to move away from that plastic metal kind of skeleton of the crazy fly. But through trying to solve one of the problems of the jellyfish frame, where they kept kind of snapping open with these carbon rods, we ended up integrating them into the body of the drone. And that ended up looking kind of like a flower. And when it was flying, it kind of looked, it even more looked like a flower. It looked like a lotus flower on a pond. So that's quite an evocative image in Tai Chi. So we took that and ran with it. And the design was based off that for the drone. So we have here Soma design and product design engineering. One is kind of slow, meandering design process, and the end result is quite facilitated, whereas the other one is quick, direct, and the end result is unaccompanied. So the design of Drone Chi was a mashup of these two. And I'll give you an example as to how that is so. The role of following the drone. We had three kinds of ways of following the drone that we prototyped. And I'll just look at the third one now. But following the drone was important because it gave you a kind of onboarding experience, a way to a kind of a hint as to how to move with this system. And so when you have when the drone was flying in an earlier prototype in a horizontal spiral, you had a lot of the people, a lot of the test participants kind of following the drone kind of aimlessly around the room and kind of just shuffling their feet backwards and forwards. But we wanted to kind of prompt an unfamiliar movement, a movement that required coordination and all that. So we flipped it to the vertical plane, and as a result, we get this kind of movement where you're shifting your weight from left and right, and you've got your feet planted. And so it was a real nice way to start the experience. So we did a user study of 32 participants, and it was to document the user experience, but also see what aspects were open to interpretation and what aspects were more prescriptive in the design. And one of the results that came out of this was this idea of a learning loop and expression loop. So at the beginning, the participants were very curious and they required a lot of focus to try and do any kind of basic move. But they quickly figured out how to move it left and right. And that would kind of lead them to this expression loop where they would try to do something more inventive. And once they kind of figured out what they wanted to do, they would kind of redo it and have a little bit of fun with it and almost fall into a meditative state. Sometimes this would lead to boredom and they would fall back into the learning loop and try again with something new. This also sometimes leads to frustration, but was part of the process, I think. Not everything was as predictable as this one, though, as evidenced by this control kind of agent versus agency result. We had a number of quotes that described the experience akin to a motor skill heavy task like driving a car or riding a skateboard. But also on the other end, we have these quotes that talk about it being like meeting a new person or riding a horse. So the breadth of experience here was astonishing as it was generative, and it led to many new ideas for the project. So after all this experimentation and evaluation, it was a great time to stop and take a look back at the question, what is it like to move a drone with your body? And equally as important, how am I going to answer this question? Or at least provide part of an answer. And research findings like this neatly categorize everything into an experience, and this would help a commercial designer predict what a similar system will do. But I think it would probably need some more rigorous testing for it to kind of push this graphic closer towards scientific fact. And it also is less helpful at coming up with new stuff than this result, which was just wild in its variance, and people were imagining things that I could not imagine what to do with the drones. So this helps generate new ideas, and I think that this kind of work in HCI is growing, and it can be seen as a concept like this can be seen as one that can be used to rationalize why one design is better than another, or it can be used to design something else. And that's kind of what I want my work to inspire other people in the field to do. So a question that I had to seriously face after Drone Chi was like, how can I deliver the most benefit to other designers? And what form should my work take? The idea I landed on was an experiential quality. Basically, properties or traits that characterize a user's experience interacting with a product or service, or a really long explanation of a really, really specific feeling. So I'm going to explain one to you now, or one that's kind of brewing, and it's called passive and active awareness. And I'll also explain later, after the break, how it will be used to design the next project. So in the design process of Drone Chi, I saw the drone go from this rough first prototype to something more polished and nuanced. And it very much reminded me of my time living with classic cars and racing go-karts in two distinct ways. There was a passive awareness. So after living with an old car for a few years, you get to understand how it typically feels. But there are always changes in this feel as things wear out and so on. So I write in a research journal, owners of old bikes and cars have a constant state of awareness of how their bodies interact with their machine. So even though I'm driving my friend home here and belting out a tune from the iPod Classic, I would still be alerted to changes in the shift if there was something wrong, or something starting to wear out. And so I would also state that designers of human drone interactions can have a constant state of awareness of how their bodies interact with their machine. So, for example, I'm sure a lot of you have experiences, maybe not even having to move with them, but when a prop needs balancing, and when the voltage sag in the battery is getting too big and all that. So even if you're doing other tasks. Then there's this kind of active awareness, and this is closer to racing a go-kart. So when driving, it was always a dilemma between reliably changing my driving style to suit the needs of the cart, or trying to change the cart to suit my driving style. So for example, I would be going around the track and making small adjustments every time, getting incrementally faster until I exceeded the limit and slid the cart. And that limit would be different on different days, depending on me and depending on the cart. And both of these things are always changing. And so this is what I mean by active awareness. And I felt the same thing with the drones, especially towards the later stages when I was just using Drone Chi in the lab for fun. And it was like a dilemma between reliably changing my movement to suit the needs of the drone, or changing the drone to suit my movement. So with this in mind, I'm in a position where I can provide an answer to this question: what is it like to move the drone with your body? But it also made me ask, what about over a long period of time? Much like the cars and the carts, how can I bake this quality into a human drone interaction? And we'll chat about that after the break. Have a quick break now. If there are any questions?
Yes, I was actually wondering which kind of mocap system are you using?
Yeah, it's so Drone Chi was on the Qualisys system with the what are they called? Number 5 is I can't remember the exact name of them now. Ocus 5. So I had 8 of those. I don't know
Yeah.
how to pronounce it. 8 of those mounted on the roof, looking down, and yeah, I had passive markers, 8mm diameter on the drone and 12mm on the hand pads, which were here. Yeah.
Yeah, with it. Yeah. Nice. If there is any other question on the, you can ask them on the chat if you want. Yeah, everybody was. I don't know about you guys at home, but everybody at Bitquiz was raising their hands and trying the.
Yeah, because I came and did a little demo a while ago,
Mm.
but you weren't there for that, Barbara.
No. Yes, so we have a question. Interesting. How smooth did the movement have to be in order for the user to stay in the flow, the kind of Tai Chi flow?
Yes, so I don't remember like the exact. So the drone was set at moving at with this code was like 100 hertz. It kept sending new coordinates to the drone, and so if you and I think as a result of that, there was like a speed limit to the drone, which I kind of didn't mess with. But if you moved your hands like about 10 centimeters away from where the I don't think I have a picture of the actual mapping here, but if you moved your hands like more than 10 centimeters away from the drone, so just to put it easily, then it would break away. But I mean, all that information is useless without me telling you the actual speed of the drone. So I'll have to get that. I'll pull that up at the end of the talk and have it in the Mybo room, I think.
Yeah. Perfect. Thanks. I don't think we have any more questions. So if you want to answer the question you asked before the break, maybe.
Me?
Yeah.
Did I ask a question before the break?
Yes.
Oh, as in, yeah. What is it like to move a drone with your body? Yeah. Well, that's the rest of the talk. Yeah. So yeah, we have this designing through passive and active awareness idea, and yeah, we're trying to use that to drive the design of the next prototype, which is called "How to Train Your Drone." A long-term, 1-month user study in an old house in Melbourne, Australia. A big old share house with a few. There was like 7 people living there, and 3 people were committed themselves to trying the drones a few times. So it was important to me that this study was conducted in a home where people could experience the drones amongst the rhythms of their everyday life, where they ate, cooked, slept, and danced. So we had 4 weeks, 3 housemates, around about 3 sessions a week. And how does this system work? Well, hang on. There's 3 people: Nina, Julian, and Tim. This system works started by taking a drone from the charger or the home. You also take 2 hand pads from the charger as well. And then you put your gloves on and then launch the drone. So when the drone is spinning, it's not paying attention to you. If you hold your hands in one place, though, it'll start to slow down, and then it will eventually snap to you. And that's when it's looking at you, and that's when it'll follow you. So you can, again, move your hands any way you like, and it will follow you. So the difference is you have to be quite still to get it to slow down. So you see here it's slowing and then start it up again because I wasn't still enough. So here we go, snap. And now you can move your hands as long as you maintain this relative position to the drone. So yeah, it was just basically a XYZ difference between the drone and the hands. And that was about 200 millimeters. And again, it was the same, in fact, yeah, it was the same speed limit as in Drone Chi. So yeah, then you can kind of move where you like, as locked into that position that you trained, as long as you stay within that around about 200 millimeters. And I say around about because each drone has a different tolerance. So eventually, you end up with this kind of history of dots around the drone, which represents where you held the drone. And each one of these points is remembered, and you can go back and grab it by these points afterwards. You also notice that they have an eye, and that eye has an eye color. Each drone has a different eye color, which corresponds to different behaviors. So we have blue, which is slow to learn, pretty easy to move by the fact that it's got a looser tolerance. Launches high, which affects how you kind of approach the drone, and it spins slow, which means that if you imagine something already spinning slow that has to slow down to 0, it's going to be harder to detect that change in rotation. So it's kind of less communicative as to when it's about to start following you. And they also have their own each distinct sound. So blue sounds like this. Amber is the quickest learner, so the fastest time to train a new position, but it's also the most difficult to move. So it has the smallest tolerance, much closer to Drone Chi. But the sounds went. Sorry, it also launched the lowest and spanned the slowest, and it sounded like this.
Yeah, no, I'm sorry, Joe, we can't hear the sound.
Oh no, that's interesting. Oh well, we'll just keep going, and I can play it later. Brown was the slowest to learn, easiest to move, launched the highest, and span the fastest. So that's not working, is it?
No. When you shared your screen, did you tick the boxes that say share the sound?
Oh, I'll have a go again. You share your entire screen?
Yes, I think so.
Yeah. Yeah, but I didn't get that.
Yeah, share system audio.
Oh, did I miss that?
There's a little box. It's okay.
That's right. All right, so that this will make a lot less sense now that there's no sound. So that's not that, you can't hear that?
No.
So we'll just skip that part. So all of that was to try and diverge the experiences of all of the participants by kind of multiplying the ways that they can move their bodies with the ways that the different drones can move their bodies, and hopefully you end up with lots of different ways of moving them. So yeah, again, this design process was a lot like Drone Chi, in that we had aesthetics and product design engineering. So we're kind of using aesthetics to tap into the feelings of racing the go-kart and all that sort of stuff, but then also using product design engineering because key things had to be communicated to the user about when the drone was paying attention to them, and using the sounds to say that it's just about to pay attention to you. Also borrowing from traditional industrial design, we were looking at how to inspire the visual look of these things, and I got very inspired by the deep sea creatures, all the weird and wonderful movements that happen down there, their alien bodies, and really trying to bring that into the design of the charger so that it kind of looked like they lived at the bottom of the sea. Also reminded me of holding jellyfish at the beach when I was younger and how weird and gross it was. So I tried to bring that out in the design of the hand pads, which you might notice, if you haven't noticed already, are just two crazy flies without any motors. And the material is like this cold, floppy plastic that you use for shower curtains called EVA. So that was really effective in conveying that sliminess of the jellyfish without being too gross. But yeah, like I said before, the interesting thing about this process was not that there's kind of like I did a lot of the semantic work already. So I had done the go-karting and the cars and the Tai Chi and watching the drone, the old prototype come to fruition. So all I had to do was kind of emulate that. And in the end, it was quite simple. I think the solution at the end is quite simple, but it started off being overly complicated, which I'll explain how now. My first mistake was trying to build something that was as capable, trying to build a system that was as capable as the Drone Chi system, as the mocap system, right off the bat, and then build from there. So I kind of committed myself to replicating the conditions of Drone Chi, which meant that moving your hands in any way you want and still having the system recognize you. So that meant adding more base stations to the track space instead of 2. I didn't know how many I could add. I knew that the maximum was 8, so I just bought 8 and stuck them all around the land room, and then tried to expand this system that was already under early development. So in hindsight, it was pretty stupid, but the forum was, as you all know, the Bible. It's the best resource, and Christopher was extremely enthusiastic about making this work, but we ran out of time. So that means now that the drones had to be facing upwards at all times. The other rabbit hole I kind of fell down was using PoseNet. I wanted this machine learning pose recognition system to track how long you keep your arms above your head, or how long you bend your knees for, and things like that. So we can kind of open up a whole range of new metrics that we can influence the drone behavior with. but looking back, there was no way I was going to be able to understand how to, effectively link these abstract metrics back to some aspect of the drone behavior. I mean, I think it's possible now, but at the time I was trying to take too big of a step into this like longitudinal relationship or longitudinal human-drone interaction. So yeah, in reality, the only two channels of feedback I had was the sound of the drones and the spinning. And couple this with letting go of PoseNet and multiple base stations, everything just kind of fell into place once you had some real like restrictions on what you could do. The last aspect of the process is like linking the sounds to cars, but you can't hear that, so perhaps I'll try and fix that at the end, and you can listen to that. But looking back at the design process for how to train your drone, it is again a combination of slow, meandering processes of SOMA design and product design engineering. Let's cover some results. So I have some results from the 5 interviews, plus a body sheet, which is just basically in order to get people to talk about what they felt in a session, it's easy to get them to draw it because sometimes we can't use our words. So they filled out these body sheets and we had to chat about them. So that made the interviews really rich. And also after trying another person's drone, we did an interview. So that was very fruitful as well because you got to understand how somebody else went about training their own drone. We also have the sets of drone handles, like the data points. So I chucked them on a scatter plot and we can have a look at them too. So, but first we'll start with Tim, the first participant. And Tim was very premeditative in how he kind of approached the flying the drone. He wanted to do this movement. He had this movement in his head that he wanted to do where his arms started wide and they came in narrow and then they went up again. So he got this idea actually because he was helping me with the base stations. And so he was kind of familiar with the system and had this idea of what he wanted to do with it. And he said that I was thinking about training the drone at specific intervals within these movements. So I was able to flow through them. And so you can see the drone pops up into another position as he moves out of the tolerance of one point and into the tolerance of another. Julian's drone had a super low tolerance for inaccurate movement. So as a result, he noticed how hard it was to move laterally as opposed to vertically and ended up having to shift his weight from his left foot to his right foot in order to kind of get this lateral movement happening. And he said that I found that when moving to the side, it's really difficult. It's quite easy to move up and down because the drone doesn't get in the way. But when you're moving laterally, you're going to bump your hand into it. So again, perfect opportunity to do some optional audience participation. I want you now to hold your hands out in front of you, palms down again. But this time it's a little bit more flat, like Julian's. And we're going to move our palms up, again in perfect sync. And back down again. And you really have to concentrate on keeping them moving at the same rate and being right next to each other. And once they're back up at your shoulders, I want you to move them to one side. So you might be seeing one hand catch up to another hand or one hand sprinting ahead. You might also be kind of turning at the hips if you're rotating to go side to side. And so this is why Julian found it easier to just hold his hands still and then just shift his weight from left foot to right foot and then move his left foot slowly to kind of keep them like that. So that was a more effective way for him to move the drone because it was just so picky. Nina's drone had the highest tolerance for inaccurate movement. So she even did a few sessions where she didn't even bother training it. She just enjoyed playing with the elasticity between her and the drone. And she said, yesterday I was like doing different training positions, whereas this time I thought, I don't want to train now. I just want to continue playing. And so, this is what I love about this project, because I don't know whether it's because of Nina likes moving in this way, or is it because of the drone is more conducive to this? Obviously, a bit of both. Now, taking a look at these handles over the course of the study, we've got Tim, we've got Nina with this kind of dense cloud closer to the drone and evenly spread. So she was kind of moving all around. Julian has like a lot of outliers and a lot at shoulder height, possibly because he also has a bad shoulder and he can't lift his hands too high. And then Tim has this, like, you can see Tim's got that, he ended up doing his like flat disc movement thing. And there's like there's a disc around the bottom of the drone and then a few up top as he launched it into the air. So some closing thoughts, some threads to pull as I finished up my PhD. Everyone came to know their own drone in their own way. So especially in how to train your drone, we didn't like push anyone to do any kind of task with the drone or something. These drones are not like a solution to any kind of problem, but when I do think about their uselessness, I think that's perhaps the reason why they're so playful and explorative and meditative. So should that be taken away or not is a question I'll be toying with. Also, you learn something new about another person when you try the drone. We didn't cover a lot of that topic in the results today, but it's there. And I wonder what are the limits to this kind of experience. Could like an occupational therapist better understand their clients through interacting through a machine with them? Could you get to know your friend or partner in a new way? Could you perhaps understand a person with a disability in a new way, or a person with an extra ability in a new way, looking forward to human augmentation and things like that? Propellers break, payloads change, and batteries sag. A fresh crazy fly feels different to an old one. So even if the firmware and the software is the same, I feel like they fly a bit different. And so if we end up in this place in the future where you can buy a machine that you get attached to in the way that I've talked about today, what happens when it's time for a new one? Is it perhaps a case for repair instead of replace? And then finally, on a technical note, it'd be really cool to move away from outside-in navigation. It takes a lot of time to set up and cart around. So can we make drone chi, or how to train your drone, using the body as the main reference? If anyone is interested in this, then let's talk. It could be computer vision or using the loco positioning system on the body or something like that. Any other feasible method, we can chat about that. So yeah, thank you for listening and participating. If you did, if you want to see more about my work, you can go to cafecharger.com. And thanks again.
Yes, thank you, Joe, for this really interesting talk. I was wondering, you said there was 3 sessions per week, but how long were the sessions?
The sessions were so it started with them sitting down and like filling out the body sheet, and then 1 or 2 goes at the drone, because there were 3 participants, but as you saw, there were like 8 drones. So if one had a problem, or they could always get at least 1 battery run out of it, which is about 6 minutes and 30 seconds. 6 minutes and 30 glorious seconds. And then they could have another go if they want. So sometimes it was 2 times that.
Okay. And how them living together, do you felt change the result or the way they have trained the drone?
Yeah, I think that being able to go down to the lounge room at any time kind of meant that they could go down in any state, that is. So if you think about a lab test, there's a time and a place, and you have to get yourself ready for it, and you stick it in your diary at a time that is good for you, but and then you have to kind of travel there, and you're in your clothes, and there's a whole thing about going there. But being in the being in the home, you can do it before breakfast, or you can do it before in between like Zoom videos, because we're in the
Mm.
pandemic. So that also changes the kind of mindset that you're in, and perhaps even the reason why you would go downstairs and use them.
Yeah, cool. And speaking about the pandemics, how did COVID affect the whole human robot interaction? Because I would guess that interest has changed when human and on-human interaction was not possible.
Mm. Yeah, so on a few levels, it changes things. Like on the like nitty gritty design side, I really wanted, like, I like the idea of them holding the drones like I was holding the jellyfish, but
Mm.
um, there was just something about them all touching them, which kind of made me feel a bit weird. So everyone had their own pair of gloves that they put the drone on. I don't know. It does change things a little bit, but it shouldn't, because you're still having to touch the drone, and they all live with each other. But these are the kinds of things that kind of push the design one way or another. Um, and also because in Melbourne we have these hectic, really, really intense lockdowns, and then times of freedom in between the lockdowns. So it was actually quite stressful to like get everything done in this time in between the two lockdowns. Because I mean, we didn't know when the next one was coming, but um, so we had to kind of have a punt, take a gamble on that. Um, so in some ways, the design of the second system was not very slow. It was like, we really need to get this done, and I think that probably contributed to a lot of the rabbit holes that I fell down as well.
Mm. Okay, cool. I don't think if there is any more question. Yeah, there is a question from Rick. Uh, Said that um, he was wondering how the different drone behaviors were they trained or pre-programmed.
Yeah, so there was nothing like trained in a machine learning sense.
Okay.
It was yeah, trained is just kind of harking to the like a inspired by the movie How to Train Your Dragon, where you like where there was the kid learns how to ride his dragon and has to change parts of himself and parts of the dragon for it to work. So yeah, there's no machine learning here. It's all pre-programmed. Basically, when the crazy fly connects to the computer just makes it sets these parameters that allow it to be easy to train or hard to train. When I say easy to train, I mean easy to set a position. So the blue one, as I said, was one of the harder ones to train. So learn a position. So you'd have to keep your hands there for at least 9 seconds before it would remember that point. And often it was longer, because you would be standing probably in front of one of the base stations, which means that you would need 9 seconds of good sweeps from the base station before you got it, which didn't always happen. So that also was another variable. Does that make sense, Rick?
It made sense to me anyway, but yes, yes, it does. Thank you. If there any more question, now is the time to ask them in the chat. But you can also meet Joe in the dedicated figure room. Maybe we can stop the recording now and